Alright, so today we'll be continuing with the vectors topic, and specifically we'll be going with one of the harder topics, which is proofs using vectors. Now, the proofs using vectors topic is a little bit complicated as the proofs can vary quite significantly, and there's no set method on how to prove it, as it'll depend very much on what the question asks you to prove and the sorts of rules about vectors that you have to use throughout. So generally speaking, the things to watch out for will be addition and subtraction of vectors, where you can use the dot product to find parallel or perpendicular lines if you're trying to prove something in a geometric shape. And you may also have to use coordinates, which will involve using addition and subtraction involving coordinates, which we've already seen, and you may have to involve things like IJ notation. Let's look at an example. Just go over the more general methods that we use to do proofs and what we have to be thinking about doing them that'll help you solve other proofs, even though they're of different formats. So let's start with this one. Given that CA from this triangle is equal to the vector A, and the vector CB is given by the vector B, and D is the midpoint of AB, and that's what those two lines denote, show that BD is equal to a half AB minus B. So, whenever you're given a proofs questions, particularly ones using geometric proofs, what you want to do is you want to label what you know. So we know that CA is our vector A, and we know that CB is our vector B. So I've just labeled that. And so now we want to look at BD, which is this vector here. And importantly, since it's BD, it's going from B to D, so it's specifically that vector there with that direction. And that's going to be equal to a half A minus B. Now, how can we get that? Well, from this triangle, we know that A and B are pointing in these directions. So if we look at the directions of these vectors, we might be able to get something similar to BD and then simplify it down. Specifically from this, it looks like we could make A from our A and our B vectors. And so what we're going to do is we're going to try and find BA, and then we're going to simplify that to find BD, because we know it's just going to be half of this BA vector, which would be going all the way along. So our BD would be in the same direction, but just half the magnitude. So how are we going to find BA given what we know about CA and CB? Well, we can use addition of vectors. So we're going to use tip to tail. And so if we started at B, we'd want to end at A. So how can we do that? Well, we could take the negative B vector, which would be a vector pointing this way with the same magnitude, because it just flip the B vector we've already got. And if we take our negative B vector and then we add our A vector, then what we're going to get is a resultant vector of from B to A along that line. So that is exactly what we would want. And if you're confused about any of that, go back to the vector addition videos we've done previously. But so from here, this means that BA is equal to minus B plus A. Hence, since we know that BD is only half of our BA vector, then this implies that BD is equal to a half of our minus B vector plus our A vector. And now I'm just going to rearrange this, or rather switch these, just so that it fits the format given. And there you have it. So we've here proven that BD is equal to a half A minus B. And we just did that by analyzing what we already knew about the triangle, and then using some basic vector addition and a bit of subtraction that we had to flip one of our vectors. But this should all be stuff you're familiar with. So a lot of these proof questions, they don't introduce any new content in terms of vectors. They simply want you to apply the content you already know in some rather creative ways. Like with this one, you might not have initially thought to use vector addition, But once you look at the vectors you've got and the vectors that you need, that should be something that comes to your mind, and that's something that you use quite commonly in these sorts of proof questions. Anyway, so now we know that BD is equal to 1/2 A minus B. So let's just clear that off, and let's look at part B, where we want to show that CD is equal to 1/2 A plus B. So what is CD? Well, CD is going to be this vector here. And so now what do we know? We know our CB vectors, we know our CA vectors, and we know our BD vectors. And if we look, it's actually rather clear what we have to do, because the vectors, we again are going to be using vector addition, and we've already basically got the vectors drawn in our diagram in that it's going to go from C to B, and then if we add our BD, then we're going to start at C and end at D and get the vector we want. So we've already basically drawn the vector addition we're trying to use, which is going to be going from C to B and then up B to D using tip to tail. So from here, we just have to do that mathematically now, and hopefully we should get this if we've done everything else correctly. So we want that CD is equal to CB plus BD, which implies that CD is equal to, and now I'm just going to substitute in what I know CB to be, which is B. So we know that's going to be plus, and what's BD? Well, we learned that in part A, which is another very common thing in proofs using vectors. You'll normally, if it's a multi-part question, you'll normally have to use the previous parts. Even if you have to do the first few parts and then you use all those first few parts on the very last part, you tend to have to use everything from the previous questions when you're working with these. So then we know that our BD vector is going to be 1/2 brackets A minus B. Now, this isn't quite what we wanted, is it? So there's one last step we have to do, which is simplification. So what we're going to do here is we're just going to simplify this expression for CD, and we should get that CD is equal to, now we're going to expand this half out to 1/2 A minus 1/2 B. So this is going to be B plus 1/2 A minus 1/2 B, which is just going to be equal to, we get B minus 1/2 B is just going to be 1/2 B, and then we pull both the halves out. So we should just get 1/2 outside of A plus B. And there we have it. We've proven that CD is equal to 1/2 A plus B. So with these proof questions, there's no, like I was saying, there's no fixed method, and you'll have to use different things each time. For example, if you're trying to prove that a triangle is a right angle triangle, you might want to use the dot product to find prove that they're perpendicular vectors of a three-sided shape, which is obviously then a right angle triangle. Or you might have to prove that something is a parallelogram, at which point you'd want to use what you know about parallel lines. Or again, you might want to prove that a certain side length is given by this expression, at which stage you're going to just be using things like vector addition and subtraction. So none of this topic is new content. It's just thinking of it in these new ways and just really taking account of everything you've got so far, and then figuring out what you need to get, and then trying to work the steps out in between. So that's the really important part, is you do what we did in this example. You take account of what you've got and then what you need, and then you try and figure out a way to get between them. It's really important that you take inventory of that. Anyway, I hope that this lesson was helpful, and I hope to see you guys in the next one.